All right. Can you see the article here?
Yep, we can see it now.
Cool. All right. So we have come out with an article that kind of gives you an idea of the different specifications that are important for a 5G gateway. So that way you can kind of compare and contrast and see what you need to look out for when you're selecting gateways. Um, the gateway is important because it runs the access gateway software for the mobile core. Um, Radios connect to it. It handles configuring the radios, connections for the phones and everything. So it's very important. Um, they need to be robust and they need to last a long time. If you're going to go through the trouble of deploying an outdoor setup, you want it to last for a long time. Um, so the reason that the hardware for the access gateway features is not built into the radios is because at the moment you can use a gateway to connect to multiple radios, or other way around, multiple radios can connect to the gateway. If you were to integrate it with radios, then every radio you deploy would have to have that additional hardware and software, and that would increase the cost. And not to mention the radios do run kind of hot, and so any added heat will make the components last less time. So it's better to split those out and more cost effective in the long run. Um, it's better to have a dedicated hardware device for the AGW rather than being cloud hosted. There can be bandwidth limitations if you are hosting somewhere that's really far away. That can introduce latency, um, network delays, and it's much more decentralized that everyone can run their own AGW rather than it being controlled maybe by Bobcat or another company or another centralized authority that's controlling the cloud infrastructure for the gateway. So it's more decentralized that way. The most important specifications that you should look for when you're trying to choose a gateway would be the processor or the CPU, RAM memory, and the network connections. So those are the component specifications, and then aside from that, you want to make sure that the gateways are made to last, that they can withstand temperatures, environmental concerns, and that they're built to run cooler. So the higher temperature electronics run at, the more they break down. So the cooler a gateway can run, the longer its lifespan will be. Um, and then with the Bobber 500, you can mine mobile tokens if you have the attached radios, but you can also mine HNT right now, which will become IoT once the hit passes for the IoT token. So you can dual mine, you'll have LoRaWAN coverage and 5G coverage. So that's a bonus also of having the dedicated hardware. You wouldn't be able to do that if you had a cloud gateway setup. For the processor, this is the component that does all the processing. I don't like it. Self-explanatory. So you want a good, fast processor that can handle the traffic that's going to be offloaded for 5G. Processors are rated by their number of cores and their clock speed. It's a good way to compare and contrast processors. And they also have a TDP or thermal design power that's kind of an indication of how much power draw they have. The more power draw it has, the higher the temperature. So lower TDP is good. For the Bobber 500, it runs an Intel Atom X6413E processor. It's got 4 cores and a clock speed of 1.5 gigahertz. And that can also boost up to 3 gigahertz with turbo mode. And it runs at only 9 watts, which is lower than some other competitive processors. For the RAM is like the short term memory. So rather than your storage, like your hard drives on a computer, which stores the memory long term, if you turn it off, turn it back on, it's still there. RAM is a short term memory. It's important because it takes things from your storage and feeds it to the processor more quickly. So the more RAM you have and the faster the RAM runs, the faster it can transfer data to the processor. And that's rated by its capacity and its frequency. So the Bobber 500 runs 4 gigabytes of DDR4, which is the newest standard of RAM, 3200 megahertz. The storage memory is important also, not so much anymore since the light hotspot took over for the IoT or the LoRa mining. You used to need a lot more storage to store the blockchain, but now we don't store the blockchain on the hotspots anymore, so that need has been reduced. But you do want to make sure that you have fast memory or fast storage memory specifically. That also helps with transferring data to the RAM and then to the CPU. So there are hard drives and solid state drives. Hard drives are like the old spinning platter drives that you would normally see in computers. These days, we see a lot more solid state drives. Those are faster, no moving parts. They don't really generate a lot of heat. They last longer, and they're much, much quicker than hard disk drives, which have the spinning platters. So the Bobber 500 runs a 64 gigabyte M.2 SSD. M.2 drives are faster than the standard SATA interface drives, which in your computer you have a cable that plugs to the hard drive and then plugs to the motherboard. In laptops, it kind of slots in. That interface has been around for a long time and has slower speeds than M.2. That can use PCI Express lanes, which are normally used for things like graphics cards, things that need to transfer a lot of data. So the data transfer is faster from that. So that can get your data off the storage and into the RAM quicker. Networking is important. You want to have gigabit ports. And like we mentioned before, if you use switches, if you're using cabling, you want to make sure that it can handle gigabit speeds. The way networking speeds work, the technology before gigabit was 10/100, so up to 100 megabit, 100 megabit speeds. So if you don't get the correct switch when you're setting up your setup and you get a 10/100 switch, you'll probably not pass that speed test because 100 down is the requirement. If you have a 10/100 equipment anywhere in the chain, that will not, 100 is the theoretical limit, but it's not going to hit that. It'll probably hit 90, 95 at the most. So you want to make sure that you have gigabit equipment. The ports on the Bobber 500 are gigabit. Both the WAN and the eNode B port are gigabit. So as long as you use a proper switch and proper cabling, you'll get more than enough speed there. And then the AGWs are an important part of the infrastructure, so they need to be secure. Carriers won't want to offload to a network that has AGWs that might not be secure. So it's very important to know that they're tamper-proof, that people can't really hack the software. So we use secure boot, which it's a way of when the computer boots up, it has a signature, kind of like your antivirus would have a signature of a virus to compare things to. It'll compare known good software and what it's reading from the storage when it boots up. And if they don't match, then it won't boot. So that's a way to make sure that no one can tamper with the software, with the firmware. If there is tampering involved, then it'll know that and it won't boot. It also has a trusted platform module. So that's a hardware component that allows cryptographic keys to be stored and allows for disk encryption. So the reason that it's better than using, say, a software program to encrypt the drive is that since it's not stored on the drive itself, if you were to take the storage out and try to put it in a different computer to access it, to do anything nefarious with it, it would be encrypted because it needs that TPM chip to decrypt the information. So that also prevents situations like someone taking the storage out of the Bobber 500, booting it on something else, messing with it, and then putting it back. So that makes it even harder to tamper with. And then The last important thing to consider is thermals. So, like we mentioned before, the hotter something runs, the less it's going to, the less time it'll last. So, you want to make sure that your gateway can run cool. So, the Bobber 500 chassis, if you notice, the actual unit of the Bobber 500 is a lot bigger than, say, the Miner 300. And it's not only because the internal components are bigger, but it's also by design because the actual chassis itself is built to draw heat out of the components and expel it into the air around it. So if you look at the back plate, um, it kind of has fins on it, almost like a heat sink would. That helps dissipate the heat out. And the CPU inside has thermal compound that connects it to a heat sink, and that heat sink is thermally connected to the back of the chassis. So the heat's generated by the components, and then it's efficiently transferred to the body of the case and out. So that's why if your Bauer 500 is running and you feel it and it feels really hot, it seems a little weird, but it's a good thing that it feels hot because that means it's expelling the heat from the internals. So it's designed to run a lot more cool. And pretty soon here, we should have an article coming out explaining the testing process that the Bobber 500 goes through. So it's run through extensive thermal testing. I won't go into super deep details now because that's up and coming, but it's put into controlled environments. It's ran at 100% very hard usage, and it's monitored. We make sure it doesn't exceed a certain temperature rating or have any errors. So that information will be coming. And then another thing to consider would be the grade of components used for the gateway. So consumer grade hardware is things like your normal home router, video game consoles, phones, things like this that you use on a daily basis. Enterprise grade hardware is higher quality. It's made to withstand heavier use and last for longer. That's things like server hardware, things that businesses would use that they rely on for uptime. And then industrial grade is a step higher than that. It withstands extreme operating environments, heavy use, things that are run in factories, military usage, things like that. So the Bobber 500 was made with industrial grade components because we know it's going to have to last a very long time. If you go through the trouble of deploying one of these setups, you want to know that it's going to last for a long time. So that's been thought of and built into the very components that we use for it. And then we also have exact specifications listed for anyone that's interested in the super technical details. It goes over all the components. It's got benchmark results for the CPU, and this is all available on our Knowledge Center. So anytime you want to look at it, um, all of that technical information is there. And like I said, pretty soon we'll have an article going over the thermal testing process if you're interested in that as well.
This is great. Thank you, William. There's a lot of really good information here and overview about the Bopper 500 gateway.